So let us start this new topic from today onwards, and I call it as work, power, and energy. So as the chapter is itself saying, what is first we need to understand the chapter name itself. Okay, and let us give the heading work, power, and energy. So we'll try to define this topic first, means we'll try to understand the essence of this topic first. First, we'll define what is work, then we'll define what is energy, and then we will define what is called as power. Because out of all these, means the point is that all these three terms are interrelated with each other. Means work is related with energy, energy is related with work. Similarly, energy is related with power, and power is related with energy. And then there is a last connection between work and power also, because energy is related between with both of these two quantities. Are you able to get me or not? So there exists a interrelation between all these points. So these all are related to do some kind of, means we are going to bring something, मतलब कुछ हम कर रहे हैं और उसी के ऊपर ये तीनों के पॉइंट के बारे में डिस्कस करेंगे. तो सबसे पहले एज लाइक बेसिक फॉर्म विल डिफाइन व्हाट इज कॉल्ड एज वर्क. बताओ वर्क क्या होता है, कुछ बताओ. बस फोर्स इनटू डिस्प्लेसमेंट इज वर्क. F into F S costed. I'm not asking the formula. I want to understand what is work. Okay, define energy first. Capacity, then power. Basically, can I say that energy is nothing but capability to do work? Yeah, so you said that same thing. Power is something called as rate of work done. Then what is work? Mm-hmm. Amount of physical change brought by a force. बोल सकते हैं क्या कि amount of physical change brought by a force is going to be called as work. And now the capability of bringing that physical change is going to be defined as energy, because if you are going to do a physical change, if you are going to do something, then you need some energy to do that or not, some stamina to do that. Are you able to get me or not? So that energy is going to be called as capability. Now, but what is power? The rate of doing work means, think of a case that there are some workers are there who wants to lift some bricks, and then they want to put it on top of a building. Got it or not? They want to lift some bricks and they want to put it on top of a building. Got it? Now if they want to bring it on the top of the building, so basically to bring it on top you need to do some work, isn't it? Now, to do that work, basically I require some energy. Like let's suppose I require 10 joules of energy to bring that particular uh, block on the top of the building. Are you able to get me or not? Now, a person is there. A person is there. One person is doing that same work in 10 seconds. Another person is doing that same work in 60 seconds. So here definitely a work is done. Definitely both of them are applying the same amount of energy also, but their application of energy, the reaction time of that application of energy is different or not. So this 10-second one guy has is going to do extra work in extra time, while this is going to do a very less work in less time, isn't it? So the connection between this, the rate of doing work was defined as power. Are you with me? Is that clear? Are you able to understand me? Okay, so we'll try to visualize this. We'll try, as we know, we are going to bring some physical change. So let us bring some physical change. Let us understand what is called as work. So we know that, let's suppose if there is a block, okay, if there is a block of mass m, I place it on a ground, on a smooth ground. Okay, this ground is smooth in nature right now, and I applied some force over here in this particular direction. Got it? Now that force, which is making some angle theta with the horizontal, displaces my particle by some distance x. Means this mass got displaced by some distance x over here. Is that clear? Or I call it as s. Okay. So basically, if we can see that there are two things happening over here. This force has two components. One is along the vertical direction and one is along the horizontal direction. Sorry, F sine theta, and this force has a component along this side, that is going to be called as F cos theta. Now the work, it was told that how much amount of basically physical change has been brought. So physical change has been brought in horizontal direction only. So that is how the work was defined, that work is nothing but vector force into displacement. Now the question arises that is the work is a vector quantity? The answer is no, because this physical change is happening in a surrounding over here, isn't it? Are you able to get me? So the work is a scalar quantity. Force is a vector quantity. Not only force, displacement is also my vector quantity. Then the question arises that how come we can connect the force and displacement, isn't it? So we know that only that, yeah, basically we need to bring the force and displacement by a product which is called as a scalar product. Yeah, because a scalar product can only give the multiplication of two vectors as a scalar quantity. Is that clear or not? Yes, so basically we got to know that the work is applied by the force and the particle is doing a displacement. Then in the magnitude form we write it as Fs cos theta, because the sine theta component is not doing any kind of work. The displacement is not there in that vertical direction. Are you able to get me? Is that clear? So work done is Fs cos theta, where S is the displacement or force. Basically, this force, this term, this F cos theta is the, it can be anything. F cos theta can be anything. It is the component of force along the displacement. Is that clear or not? Now, as we know that a block consists of many particles, isn't it? If you see a block, then whenever I consider a block whichsoever I place, so let's suppose I place this block over here, isn't it? Now, as I know that this has many number of n number of particles spread over there, isn't it? Now, this is not a block. Consider it to be a soft form. क्या है? Okay. Consider it to be a soft form. Okay, I'll take a bigger picture of that because it's necessary to understand this. ठीक, ये क्या है? एक सॉफ्ट फॉर्म है और इसको मैंने क्या कहाँ रखा है? एक ग्राउंड पे रखा हुआ है ना? ठीक, तो बोल रहा है कि अगर मान लो इस सॉफ्ट फॉर्म के ऊपर और यहाँ पे एक दीवार है ना? इज दैट क्लियर? हाँ, देयर इज अ वॉल ओवर हियर and this is my soft form. Now I applied a force at the center of this soft form over here. Now you know that a soft form has many particles. Yes. So what will happen? The basically you will see that the soft form, in the soft form, the particle which is present over here is going to get displaced maximum, isn't it? Then the particle over here is going to be displaced a little bit less. The third little bit much more less. This will be little bit much more less, isn't it? So basically what I'm going to observe is that I'm going to observe a curve like this way. When you apply a force on the soft form, you will not see a perfect movement, but you will see what a curve kind of thing, means a curve like, yeah, isn't it? It can be anything. It cannot be parabola or something like that, but definitely I'll observe a curve, isn't it? So then the question arises that over here I can see that there are many displacement. Consider it to be delta S1, delta S2, delta S3, delta S, delta S4, or so on, isn't it? There are many such displacements over here or not. Then the question arises over here, how do we define the work? How do we define the work? चलो कैसा है क्वेश्चन, मस्त है ना? तो देखो सिंपल सी बात है, अभी अभी अब यही चीज बताने जा रहा हूँ कि बेसिकली द वर्क की जो डेफिनेशन है वो हम लोग गलत पढ़ते हैं। हम सोचते हैं कि हम फोर्स लगाएंगे ब्लॉक मूव कर जाएगा, ऐसा नहीं है। फोर्स जब हम लगाएंगे तो फोर्स उसी पार्टिकल को मूव कराएगा जिस पार्टिकल पे वो एक्ट कर रहा होता है। मतलब वर्क इज डिफाइंड फॉर वन पार्टिकल सिस्टम। It is going to move, but the work will be only due to the one particle where the force is applied. No, we will not consider like that. We'll tell you. So what we will consider that this block has although many points, but the force of application is at this particle only or not. So the work will be defined as that the force applied on that particle and the displacement done by that particle. Is that clear or not? Means the displacement must be considered for the particle on which the force is applied. Is that clear? So delta S must be considered for the particle on which the force is applied. Otherwise, you are never going to consider the delta S. Is that clear or not? Yes. Now, as I know that our force is a vector quantity, so F can be written in terms of like you know that Fx I cap, the force of x along I cap, plus force component along y into j cap, plus force component along z into k cap, isn't it? Now, similarly, I can have the displacement. We know that displacement vector is represented by delta r. Yes, yes, no, and that is written as x2 minus x1 I cap plus y2 minus y1 j cap plus z2 minus z1 k cap, isn't it? So basically, for this, the work done, as I know that these are the dot product, I know that I cap dot I cap is 1, j cap dot j cap is 1 while k cap dot k cap is 1 but other terms are always 0. ये हमें मालूम है ना. So basically other terms are always how much? 0. So if they are 0, then the work done will be defined as f of x, x2 minus x1 plus f of y, y2 minus y1 plus f of z, z2 minus z1. This is going to be my term or not? So this is my formula of work for a constant force and a constant displacement in which form in the three-dimensional form. Are you able to get me? So this is my work done in three-dimensional Cartesian coordinate. Is that clear? Are you able to understand me? 3D Cartesian coordinate system. Is that clear or not? Now let us just do one thing. As we know that the force can be variable also, isn't it? So if the force becomes variable, if the force in three-dimensional coordinate system becomes what? Variable, then that force means let's suppose if इसका मतलब क्या हुआ कि force जो है ना वो x कोऑर्डिनेट पे भी वैरी करेगा, y कोऑर्डिनेट पे भी और कैसे वैरी करेगा z कोऑर्डिनेट पे भी. तो जैसे हमने लिखा कि f वेक्टर है, f वेक्टर क्या होता है fx प्लस fy j कैप प्लस. तो जो वर्क डन होगा उस टाइम पे अगर थ्री डायमेंशनल कोऑर्डिनेट पे वैरी करने लगा तो क्या होगा इंटीग्रल f ऑफ x dx from x initial to x final plus f of y dy from y initial to y final plus f of z dz from z initial to z final. This is my whole equation for the work done for the variable force in the case of three-dimensional coordinate system. Are you able to get me or not? Understood? That means if the variation is in only one coordinate, means if force varies along x direction only, then work done is simply x initial to x final force f into x dx. Are you able to get me or not? Understood perfectly? Now the question arises that the force can depend upon path. These equations means that force is dependent upon path, isn't it? राइटिंग अगर मैं एक्स वाई जेड के टर्म्स में फोर्स को लिख रहा हूं तो इसका मतलब क्या है कि सिंपल सी बात है इज डिपेंडेंट ऑन पाथ, है कि नहीं. लेकिन अब ऐसा भी तो हो सकता है ना कि फोर्स टाइम पे भी डिपेंड कर सकता है. बोलो. मतलब 1 सेकेंड पे मैंने पहले 1 न्यूटन लगाया और दूसरे सेकंड पे मैंने कितना लगा दिया 2 न्यूटन लगा दिया तो फोर्स वैरी किया ना टाइम के रिस्पेक्ट में. इट इज नॉट अ कांस्टेंट फोर्स. So let's suppose if I represent that force depend upon time as Ft, force dependent on time. अगर ये फोर्स डिपेंड अपॉन टाइम से Ft से हम रिप्रेजेंट कर रहे हैं तो जो वर्क आएगी वो कैसे निकालेंगे. अभी एक बड़ा सा क्वेश्चन बन जाता है ना, क्योंकि हमारे पास तो वर्क होता है फोर्स इनटू डिस्प्लेसमेंट तो उसका इंटीग्रेशन तो आसान है, लेकिन अब भी कैसा है ये फोर्स इनटू टाइम है. फोर्स डिपेंडेंट अपॉन टाइम है मतलब जो इक्वेशन होगा वो कुछ इस तरह का होगा F इज इक्वल टू टी स्क्वायर प्लस 2t या फिर कुछ इस तरह के इक्वेशंस होंगे. तो अगर हम इसको वर्क डन की इक्वेशन में डालेंगे तो ये सॉल्व होगा क्या, किसको क्या करेंगे हम डिफरेंशिएट करके कैसे निकाल सकते हैं. What is df by dt? Nothing. So basically, how to proceed this? Let us understand that. So we know that if force is dependent upon time, then I can write it as mass into acceleration, which is dv by dt or not. Yes, is that clear? Now, if force is dependent upon time, then I can write v is equal to m into f into t dt. और अगर मैं इसको इंटीग्रेट कर दूं फ्रॉम v इनिशियल टू v फाइनल, या फिर मान लो मैंने इसको इंटीग्रेट कर दिया, dv, सॉरी सॉरी dv था, dv को इंटीग्रेट कर दिया है ना, तो क्या बचेगा? वेलोसिटी का इक्वेशन आएगा या नहीं आएगा? आएगा ना। ये क्या देगा तुम्हें? वेलोसिटी का इक्वेशन। दिस प्रोवाइड्स यू velocity equation. So velocity at any time can be found by replacing, I'll tell you, by replacing time in the equation. मतलब अगर मैंने टाइम इनिशियल और टाइम फाइनल डाल दिया, इससे देखो एक इक्वेशन मिलेगा है ना। अब टाइम इनिशियल टाइम फाइनल डाल दिया तो मेरे को v इनिशियल v फाइनल मिलेगा या नहीं मिलेगा? वेलोसिटी एट एनी 2 पॉइंट्स मिल जाएगा ना। अगर जैसे ही वेलोसिटी एट एनी 2 पॉइंट्स मिला, यू नो दैट वर्क डन is nothing but change in kinetic energy of the system. So which is what? Half m v square. So if force is dependent upon time, then work done can be rationalized as half m common, so m square common, integral f t dt whole square, and do this integration from t initial to t final. Are you able to get me or not? What? F times v. No, how come we can write F times v? That's power. Wait on. So, okay, do not replace t initial and t final. If you do this integration, so this, like, find the velocity. Okay, there is a square on top of that, no? So it will change. It will change if I replace it. Okay, so just do one thing. Means first find the particular velocity. First find this particular integration for the final time. Okay, so this will be a square for t final. Got it? And then integral f dt, okay, for the t initial. This equation for the, I'll tell you. Is that clear or not? Means the concept is same. Just find just find the velocity, replace t initial and t final, you get the two velocities, and then put in change in kinetic energy equation, because here already m is present, so it will come as half mv square, so it will come as half m square. Are you able to get me or not? तो कर लोगे इस तरह का क्वेश्चन, है कि नहीं? तो अपने पास क्या मालूम चला कि सर आपने तो बहुत अच्छी चीज बता दी। पहले तो कि फोर्स का नॉर्मल स्केलर इक्वेशन क्या होता है, दूसरा फोर्स पार्टिकल पे लगता कैसे है, तीसरा फोर्स अगर वेरिएबल हो जाए और मतलब फोर्स पहले 3 डायमेंशन में कांस्टेंट हो तो क्या लगाएंगे, फोर्स 3 डायमेंशन में वेरिएबल हो तो क्या लगाएंगे, फोर्स 1 डायमेंशन में वेरिएबल हो तो क्या लगाएंगे, और अल्टीमेटली फोर्स टाइम पे डिपेंड हो जाए तो क्या लगाएंगे, है कि नहीं? लेकिन अब एक बात आती है कि सर इतना हमारे नीट में थोड़ा सा तो इजी आएगा ना। और वो इजी कैसे आता है? अगर मान लो हम लिखते हैं वर्क डन इज इक्वल टू इंटीग्रल फोर्स इनटू डिस्प्लेसमेंट एफ डॉट डीएक्स, है ना। और हमारे पास जो ग्राफ है वो फोर्स और डिस्प्लेसमेंट की एक ग्राफ दे दी गई है, ठीक है। इधर फोर्स लगा हुआ है, इधर क्या लगा हुआ है, डिस्प्लेसमेंट, और ग्राफ कुछ इस तरह का है, ठीक ठीक। या फिर एक काम करते हैं, कर्व ही बना डालते हैं, ठीक। अब थोड़ा अच्छे से हो जाएगा, है ना। अब अगर ये कर्व दिया हुआ है तो ध्यान से देखा जाए तो हमने एक तुम्हें ट्रिक बताया था कि इफ C is written as A into B, then area of graph AB can give me the quantity C irrespective of their vector or scalar, isn't it? Hmm? So if I look into over here, for this is also like same work done is equal to force into displacement. So can I say that work can be found out by the area of graph force into displacement? Now the question arises that here there are two areas. One area which is in upward means positive quadrant, one area which is in negative quadrant, isn't it? So then here it definitely matters actually. The positive quadrant work will be positive and the negative quadrant work will be negative. So net work done will be always equal to area पॉजिटिव, ठीक है। हाँ अगर मान लो देखो अगर तुमने नेगेटिव यूज कर लिया तो फिर अगर तुमने नेगेटिव बोल दिया है तो यहाँ पे माइनस नहीं लगेगा, प्लस एरिया सेकेंड, ऐसे मतलब ऐसे यूज करो, ऐसा टर्म यूज करो, एरिया वन प्लस एरिया टू प्लस एरिया थ्री एंड सो ऑन। और इसमें साइन इंक्लूड करो, ग्राफ में साइन इंक्लूड करो, तो पहला एरिया पॉजिटिव रहेगा, दूसरा एरिया कैसा रहेगा, नेगेटिव। आर यू एबल टू गेट मी? Minus area of negative, that's all. So work net becomes whatever it will come. Is that clear? Understood? So these are all the basic fundamental properties of work done। ठीक है, तो अब इसके ऊपर थोड़ा सा अपन पीएचडी करें, थोड़ा अच्छे अच्छे क्वेश्चंस पकड़े है ना। चलो, तो let us do let us bring some questions over here। पहला एक क्वेश्चन स्टार्ट करते हैं बेसिक स्ट्रक्चर से। मान लो एक ब्लॉक है, ठीक, जिसके ऊपर मैंने एक फोर्स लगाया, I applied the force, ठीक है, an angle theta is equal to 37 degree and this force was equal to 50 newtons। ठीक है, बोल रहा है कि फर्स्ट and the surface is smooth, so question is find the work done in t is equal to 3 seconds। बताओ, find the work done in t is equal to 3 seconds। now बताओ क्या होगा। Uh-huh. You have to find the particular work done in 3 seconds. Hmm. क्या होना चाहिए? अच्छा देखो, क्वेश्चन पहले समझो। पूछा है find the work done in t is equal to 3 seconds. Now that means the particle, I have given the force, then and this surface is smooth, then the particle is going to move, isn't it? So the question is that first find the understanding that what is the displacement in 3 seconds. Okay, first find s is equal to 1. Then how to find that? Now if I apply a force, then the body will, let us consider that the body starts from rest. Okay, so the body will travel some distance in 3 seconds or not? How to find that? Let us see. So how to find that how much distance it has traveled in 3 seconds? First, I'll apply. Yeah, so you will see that uh, the force has two components once again over here. One is F cos theta, which is 50 cos 37, and this is 50 sine 37, isn't it? 50 cos 37 becomes how much? 50 into 4 by 5. So that means that is how much? 40 newtons. Is that clear or not? So this is my force in which direction? Horizontal direction. Isn't it? Now I know that any force in the horizontal direction will accelerate the particle in that direction. So acceleration will become how much? Oh shit, I didn't have given mass to you or what? So let us consider that mass is 5 kg. So acceleration becomes how much? Definitely 40 by mass m, which is 5. So that becomes how much? 8 meter per second square. So definitely the displacement half at square. Yes. So s is equal to basically ut plus half at square. Initial velocity is 0. So I'll not consider t plus half. Acceleration is 8. Time is 3 square. 4. 3 is a 9. 4 is a 36 meters, isn't it? Basically, the displacement done in 3 seconds is how much? 36. So work done as the work is only done. अब ध्यान से देखो, जब work done लिखेंगे ना तो हम पूरा का पूरा force नहीं लिखेंगे, क्योंकि हमें मालूम है कि this force is only doing the work. This force is just idle, isn't it? So work done becomes 50 cos 37 into 30. So 50 into 4 by 5 into 36 calculated. That is my work done. Is that clear or not? Understood? Can we move ahead? Now, let us imagine one case. That's a very awesome case which I am going to do. So, let us imagine it. Uh, Let me check whether there are, what are these interactions? No, not that. Pictures, no. Only, okay, shapes are there. Okay, let us imagine one case that we have a truck over here. Okay, means there is a truck which is going. Okay, let us just let it. I'll draw by myself. There is a truck which is moving on a road. Okay, and let's suppose this truck has an acceleration. So there is a person who is driving it. Okay, I don't. You have heard about that DJ wale babu mera gana chala do na? Yes. So I just took my truck and I just took it and I'm just taking it. I'm just moving it in such a way that there exists an inclined plane over there. What exists over there? And on that there is a mass. Mass considered to be 2 kg. Is that clear? Inclination is 37 degree. Right about. Now, if I look over here, the wheels are also moving. These two wheels are moving and moving. There are two persons. The particular truck has at that instant of time some velocity. Okay, so let us consider some acceleration. Okay, let's suppose I call it as 5 meter per second square. I think this is going to be a little bit tough. Okay, now this is a question. I'll first we'll discuss about the theoretical aspect of that. We'll come on this question a little bit later on. But first we'll discuss the theoretical. There are two observers, one sitting on the ground, one sitting on the truck. Is that clear? Now think of one case. Basically, for the person, basically, if I just consider, let us this consider observer A and B. So can you tell me which observer is inertial and non-inertial? First tell me which observer is inertial and which observer is non-inertial. Which observer is it? B. B is in correct. B is in non-inertial. Non-inertial. Sorry. So basically, we give that idea now that how to consider non-inertial and inertial. Simply for non-inertial, what should happen? Basically, for non-inertial, the frame should have an acceleration. Yeah, is that clear? For observer A, it is on inertial because it is at rest. The frame is at rest for it, isn't it? Now, if I have inertial and non-inertial frame, now look for the B. What B will observe? What will be the observation by the B? Consider that the block is at rest over here. Means there is this surface is rough. Okay, the surface is rough and the block is at rest over here. Are you able to get me? So now look over here. So if the surface is rough, then what B will observe? B will observe that the particle is at rest over there or not. Definitely it is going to observe that. Yes. So basically with respect to B, is the block is doing any kind of displacement? No. So basically with respect to B, with respect to B, the block is not doing any kind of displacement, isn't it? So if the block is not doing any kind of displacement with respect to B, then the work done by any of the forces present on that block must be equal to how much? It will be how much? Zero. Perfect. Basically ये जो 2 kg का जो ब्लॉक है अपन का ये यहाँ पे अभी कोई डिस्प्लेसमेंट कर ही नहीं रहा है बी के रेस्पेक्ट में है ना चाहे कोई भी फोर्स यहाँ पे लग रही हो तो उन सारे फोर्सेस की वजह से जो डिस्प्लेसमेंट है वो कैसा है जीरो है तो वर्क डन कैसा हो गया जीरो वर्क डन कैसा हुआ जीरो इज दैट क्लियर और नॉट but if I look with respect to A what will be the work done if I look with respect to A what will be the work done it is going to be some quantity isn't it every force will have a different work done over there isn't it basically can we say like that so with respect to A the with sorry with respect to A what is happening with respect to A the particle slash block is displaced, isn't it? So, work done by any force with respect to A means कुछ ना कुछ मतलब सारे forces ऐसा नहीं है with respect to A is not going to be zero, isn't it? Basically, it can be positive, negative, zero also means anything is possible over there with respect to A. Are you able to get me? Zero can be possible. Like if the force is perpendicular, then are you able to get me or not? Yeah. Is that clear? So, what do you observe? You observe one basic property that when we change the observer, the work is getting changed over here or not? When we change the observer, the work also changes, isn't it? So, if we change the observer, the work also changes. That means that brings us to one of the biggest conclusions that work done is frame dependent, isn't it? So we got many properties of work done. First was work. If I have forces, then can be with respect to path and all. We got many force formulas that work done is equal to Fs cos theta. It was also equal to integral F dot dx. It was also equal to integral Fx dx I cap, Fx dx plus Fy dy and plus fz dz. All these properties, these three different formulas we got. Then fourth formula we got work done is equal to area under the fs graph, and most importantly positive area is equal to positive work, negative area is equal to negative work. So these were the different properties we got out of the work over there. So this is your whole conclusion of work power, work in the different frames, different force relations, and all those kind of properties. Are you able to get me? Then let us we did one case. We were doing one case. Let us solve this question now. Let us try to imagine this question. Let us describe it. So first task will be to understand the development of this problem. First task, and that task will involve the most important thing which is called as resolution of forces first of all, isn't it? So we will not bring draw these all these trucks and all. We just know that in this diagram work done due to B is always how much? Zero, because the particle is at rest. That means friction is definitely present over here, isn't it? Yes, the truck is going with a 5 meter per second square. So this block will feel a pseudo force of 2 kg into 5 means consider it to be okay. Let us means m into a acceleration of the frame in the opposite direction or not. Basically, are you able to get me or not? Pseudo force, yes. So let us just draw these diagrams and then we'll talk about that. So we'll just take the consideration of inclined plane directly. Got it? So this is my inclined plane over here, and it is placed on top of it, isn't it? A block is placed on top of that. So let's suppose it has mass something m, or I gave it 2 kg, and the frame was accelerating. So due to the frame acceleration, it is failing 10 newtons. 5 twos are 10 newtons towards this side, isn't it? Because the whole thing was accelerating with 5 meter per second square. Are you able to get me or not? Is that clear? Now, mg is also working. This angle is 37. Mg is also working. Yeah. So basically, we calculated mg means 2 into 10, that is 20 newtons, isn't it? So for this mg, there will be two components. Mg, definitely this is going to be 37. So 20 cos 37, and one will be 20 sin 37. Sorry. Yeah, actually, I took a wrong angle. 1 minute. Yeah. Basically, this is 37. So this is 20 cos 37, 20 sin 37, isn't it? So this is 20 into 3 by 5. 5 4s are 20. 3 4s are 12 Newton. This is how much? 20 cos 37 is 4 by 5, isn't it? So this is 16 Newton. Now, this is going to be my normal. Yes. And this is going out to be my frictional force, which will oppose the body, and it will bring the body in rest or not. Body is in what condition? Rest or motion? Rest. Now, out of all these, I asked you, find the work done by friction or anything. Find the work done by all forces. लिख लेते हैं पहले. Find the work done by all forces in 2 seconds, है ना? Are you able to get me? तो ध्यान से देखा जाए तो बेसिकली अगर ये एक्सेलरेट किया तो जो डिस्प्लेसमेंट आएगी वो क्या आएगी? हाफ ए टी स्क्वायर, यही आएगी ना? तो डिस्प्लेसमेंट कितना आएगा? डिस्प्लेसमेंट आएगा हाफ एक्सेलरेशन 5 इंटू टी स्क्वायर विच इज 2 स्क्वायर, तो कितना आया? 10 मीटर्स. है कि नहीं? तो ये जो डिस्प्लेसमेंट अगर ध्यान से देखा जाए तो डिस्प्लेसमेंट की डायरेक्शन इस डायरेक्शन में होगी ना, 10 मीटर्स, जिस डायरेक्शन में ट्रक मूव कर रही है कि नहीं? आर यू एबल टू गेट मी? इज दिस अंडरस्टूड? नाउ if this angle is 37, so this angle will be how much? 53. So this angle becomes how much also? 53. Yes. So work done. The first force I'm calculating with respect is with respect to normal. So work done due to normal will be what? It will be, as you know, the normal force is represented by mg cos 37 or not, because it is at rest. So it will be how much? 16 mg cos 37 into the displacement, which is 10. And after that, once again, this angle will be multiplied by cos 53 degree. So equation is what? Mg cos 37 into my displacement into my cos 53 degree. Are you able to get me or not? So this big equation gives the work done by the normal. Is that clear or not? Got it? You put the values, you'll get the work done by normal or not. Next thing you notice, if I find, look over there, if I try to calculate work done by mg. Now, if I look due to the work done by mg, this is my mg. This is basically perpendicular to my displacement or not, so it will be equal to how much? 0. Is that clear? Work done by pseudo force. Yeah, pseudo force is how much? 10 newtons. 10 into 10 into cos 180 degree. Cos 180 is minus 1, so minus 100 आया या नहीं आया? लास्ट बचेगा फोर्स वर्क डन ड्यू टू फ्रिक्शन. अब ध्यान से देखा जाए एक बात बताओ जरा, अभी बॉडी रेस्ट पे है तो फ्रिक्शन की वैल्यू कितनी होनी चाहिए, विच इज हाउ मच, इज इट गोइंग टू बी 12, थिंक, 1 minute, oh shit, there is a pseudo force also over here now, shit, I didn't resolve the component of pseudo force actually. This is 10 Newton, no? So due to 10, yeah, so this will be 10 cos 53 degree over here, and along this direction, the component of 10 will be how much? 10, 53. So in normal, we'll have to, this work done by the normal will be also due to 10 cos 53 or not. Is that clear? Uh-huh. Basically, the normal is exactly equal to 2 cos 37 plus 10 cos 53, na? So this is the normal due to the mg sin theta component. But since the pseudo force is also present, due to that also the normal will appear or not. Got it? So that is why it will have also a component. Yeah, 10 cos 53 into displacement 10. But what's the angle now? This whole big angle I have to consider or not? यहाँ से लेके यहाँ तक मानना पड़ेगा ना, या फिर सॉरी नॉर्मल से हम निकाल रहे हैं ना, ये वाली एंगल, ये वाली एंगल है ना, सो दैट विल बी नथिंग बट 10 into cos 53. Is that clear? Is that clear or not? Basically I'll tell you simple thing. देखो pseudo force लग रहा था तो यहाँ पे दो कंपोनेंट आएगा, एक होगा mg sin थीटा का, और इधर ये mg था है ना, ये एंगल क्या है थीटा, तो ये एंगल मान लो 90 माइनस थीटा है ना, ये हो गया तुम्हारा नॉर्मल और इधर हो गया तुम्हारा डिस्प्लेसमेंट, तो ये एंगल कितना हो गया 90 माइनस थीटा, है कि नहीं? इधर स्यूडो फोर्स है, स्यूडो फोर्स का एक कंपोनेंट आएगा, इधर क्या आएगा एम ए कॉस 90 माइनस थीटा, आर एबल टू गेट मी और नॉट? So this becomes what, equation becomes वर्क डन इज इक्वल टू, दो फोर्सेस है सेम डायरेक्शन में, नॉर्मल की वैल्यू है एम जी साइन थीटा प्लस एम जी एम ए इंटू एम 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 ए एम ए एम ए cos 90 minus theta into the displacement s into once again cos 90 minus theta, because the normal is making this time with the displacement 90 minus theta. Is that clear? Understood now? Yeah. Okay. Are you able to get me? Is that clear or not? So I'm just deleting this part. So basically, work done by friction will be same, because there are, first thing is this is my mg sin theta 12 Newton. 10 sin 53 is how much? Is 10 into 3 by 5. That is how much? 6 Newtons. Yes. So basically, if the body is at rest, so along the inclined plane, this friction plus 6 Newton must be equal to 12 or not. So this implies friction is equal to how much? 6 Newtons only. Are you able to get me or not? So 6 into displacement 10 meter. Once again, displacement is 10. And what's the angle between all these over here to here? This is 90 plus 53 or not? This is that only angle ना, ध्यान से देखो. If I look over here, this is my friction which is perpendicular on my normal, isn't it? This angle is 53 given, so that angle becomes how much? 90 plus 53. Is that clear? So this becomes how much? Cos 90 plus 53. So it is your task to solve all these and put the values over there. Is that clear or not? Understood? थोड़ा हार्ड दे दिया था है ना, लेकिन कॉन्सेप्ट पूरी तरह से क्लियर हो गया. कॉन्सेप्ट पूरी तरह से क्लियर है ना? हम्म, ठीक है. तो बस इसको ऐसे ही लगा दो, आंसर आ जाता है कि नहीं? मतलब पॉइंट ये है कि वर्क में इतना ज़्यादा टेंशन नहीं लेना, टेंशन सिर्फ जो भी तुम्हें डायग्राम मिलता है डायग्राम को सॉल्व करो, आंसर आ जाएगा, है कि नहीं? ठीक, अब थोड़ा थोड़ा टिपिकल टाइप प्रॉब्लम पे जाते हैं। मान लो बोला कि जो फोर्स है ना वो कुछ इस तरह से वैरी कर रही है। लेट अस सपोज द फोर्स इज गिवन एज द, बोला गया कि द फोर्स मस्ट डिपेंड अपॉन पाथ एज dependent on path as f vector is equal to x, sorry, या फिर not f vector, just f is equal to x square minus 2x. What is given? F is equal to x square minus 2x. Then question is, if the particle is taken from, means if the particle is taken on the x axis from 2 meters to 5 meter, then find the work done. Then find the thing. Yeah, you have to, if the force is path dependent, इसका मतलब क्या है कि हर पॉइंट पे फोर्स की अलग अलग वैल्यू है। यही मतलब है ना। ऐसा है कि ऐसा है ये पाथ है ना। अगर पाथ इफ दिया है एक्स स्क्वायर माइनस टू एक्स, तो पाथ भी उल्टा सीधा है। हर पॉइंट पे फोर्स की कैसी वैल्यू, अलग 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 अलग। पाथ कैसा है, अलग अलग। तो उसको हम छोटा छोटा पार्ट मान के ऐड कर देंगे तो क्या मिल जाएगा, अपने वर्क डन मिल जाएगा। बताओ कितना होगा। अच्छा, how much it is coming? 18. Okay. मतलब if I write work done is equal to integral f into dx, variable x है तो f into dx, f dot dx basically. Are you able to get me or not? This becomes x square into 2x dx. So this appears as what, x square dx minus 2x dx. Integration is from 2 to 5. Both are same variable, so 2 to 5. I think this will be x cubed by 3 from 2 to 5 minus 2x square by 2 from 2 to 5. How much you are getting then? This is 18 joules. So I think this will get as 18 joules. Are you able to get me or not? Now let us bring another variation. Let's call f is equal to 2x I cap minus y square j cap, okay, plus y square j cap, and it is taking the particle from 2 points, point A to point B, This force is taking the particle from point A to point B. Call point A as 1 comma 1 and this is 2 comma 3, or make it sorry 3 comma 2. Is that clear? Then the question is find the network. बताओ. Yeah. Hmm. बताओ होगा. Root 5. Let us see. So work done. Now this is, if I look into the variation, there are two variations, one along x, one along y, isn't it? So can I just consider the variation along x as fx and variation along y as fy? So what was the formula? Integral f of x dx plus integral f of y dy. So work done becomes what? Integral 2x dx plus integral y square dy. But x, look over the variation of x. X is taken from where to where? 1 to 3. So that's all, integration from 1 to 3, and this is taken from 1 to 2. So this becomes 1 to 2. So the equation becomes 2x square by 2 from 1 to 3. 2 2 cancel, plus this becomes y cube by 3 from 1 to 2. Equation becomes 3 square minus 1 square plus 2 cube by 3 minus 1 cube by 3 joules. यही होता है ना इक्वेशन. बन गया, बन जाएगा. कंफर्म. Okay. So can I move ahead? Okay, there is one more question. So basically you can do these kind of questions easily, isn't it? Write one more question. Third type, if f vector is equal to 2xy. One minute, sorry. Sorry. Uh, 1 minute. 2xy I cap x square. Hmm. Hmm. Okay. 2xy I cap plus hmm, plus x square j cap. ठीक है? Hmm. And with this help of force, again I'm taking the same particle from A to B. Okay. With the coordinates 1 comma 1 to 2 comma 3. Then tell me, yeah, then tell me that how much is the work done required. माँ हाँ मैं ऑनलाइन क्लास ले रहा हूँ कुछ बात है क्या कौन सी कुछ हाँ माँ हम ऑनलाइन क्लास लेते हैं कुछ बात है हाँ 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 वो पूरा पूछा कराने की कितना लागी कितना ऐसा कोई हम्म हाँ हाँ हम बल्ली हैं कहाँ कहाँ हम्म 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 हाँ पता है भाई मेरे से मांगे हुए नाम का सभी हम्म 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 हाँ 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 हम्म 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 कहाँ ना ऐसे कुछ बोलना नहीं होता है। अच्छा ठीक है। हुआ क्या सृष्टि, हुआ बना या नहीं बना? There is an issue. Yeah, I know that there is an issue. That's what I have given you to imagine. Okay, think it, think about it. माँ हम थोड़ा कॉल करते हैं, क्लास लगा ठीक ठीक हाँ okay. Okay, let's see what's the issue. Let's I know that, I know that, I know that. So that's why I have given the question. So work done becomes integral f of x dx once again plus f of y dy. This is y fy and this is f of x now. Why? Because the I component will be called as x and y component with the j cap will be only called as y component. Is that clear? So that becomes 2xy dx plus x square dy. Can I write in whole integration or not? Now, just imagine one thing. Let's suppose I take a differentiation of component d by dx of x square y. I take a differentiation of what component? 1 minute, 1 minute. I'll tell you why. You see that. You see a chamatkar then. If I take a differentiation of x square y, what I will get? I'll get 2xy. Yes. And then there will be a chain rule over here or not? Because these are two different variables. And x square, yeah, x square into dy by dx. Is this is going to be my term? Just send this dx. Just now send this dx on the right hand side. Okay. So what I will get? D of x square y is equal to 2xy into dx plus x square into dy. I just sent that dx in the right hand side. That's all. I just multiplied with the right hand side. Is that clear? Are you able to get me? That exactly matches with the equation I given over here or not? And that is why this integration can be written as integral just x square. Sorry, they are doing that work. Due to that, many sounds can come. D of x square y. Can I write like this way or not? 1 minute. I'll mute it. Just 1 minute. Okay, can you hear me now? Okay, so basically, this d of x square y can be written like this way or not. And these things, this particular way of writing these equations are called as perfect differential form. Because integral into d is just nothing but x square y. The result of work done is just x square y. And this x is going to vary from 1 to 2 and y will vary from 1 to 3. So equation will become 2 square minus 1 square into 3 minus 1. That's all. So the result of work done is 4 minus 1, that is 3 into 2, which is where did just now you see this is my equation over here or not? 2xy into dx x square dy. So this can be represented. See, I can't do this integration in a similar way because there are two different variables over here. So what I did, I just wrote it into a form which we call it as perfect differential form. क्या बोलते हैं इसे अपन? So whenever you have the components dx and dy at the same instant of time, and you see that with the dx there is another variable y, and with the y there is another variable x, then yes, there is a chance that that can be represented in terms of a single variable equation, which can be written as d of x square y or d of x square y square, या फिर ऐसा कुछ ना कुछ equation बन सकता है अपने पास. Are you able to get me or not? Understood. So then if I do the integration of d of x square y, this got neutralized. So what is left with x square y only or not? and x varies from 1 to 2, so it will become what? X square 1 to 2. The equation can be written as like this way: x square 1 to 2 and y from 1 to 3. Put the limits and then multiply, you will get the answer. Is that clear? So this is called as a perfect differential form. इस तरह के जो इक्वेशंस आते हैं ना, जो तुम्हें मतलब पूछे नहीं जा सकते, इट इज अ काइंड ऑफ एक्स्ट्रा फॉर यू, बट दीज आर कॉल्ड एज which kind of forms? Perfect differential form. Yeah, so basically I'll give you a sheet of 5 questions of different kind of perfect differential form. उससे ज्यादा कुछ पूछ नहीं सकता है, वो बहुत टफ लेवल का हो गया. Are you able to get me? Understood. So what do we observed actually? ध्यान से देखो. तो अपने पास तो पहले तो ये कांस्टेंट वर्क है, तो कांस्टेंट वर्क के अलग अलग वैल्यू आ गए. वेरिएबल वर्क, जब वेरिएबल फोर्सेस लिया उसके लिए भी, जो यहाँ पे देखो ये वर्क की जो न्यूमेरिकल वैल्यू आ रही है वो कैसी आ रही है? कांस्टेंट आ रही है ना. कांस्टेंट आई या नहीं आई? यहाँ पे भी कांस्टेंट आया, यहाँ पे भी कैसा आया? कांस्टेंट. तो जब भी किसी ऐसे फोर्स के लिए वर्क की वैल्यू कांस्टेंट आ जाए या फिर जीरो आ जाए, तो उस तरह के फोर्सेस को हम बोलते हैं कंजर्वेटिव फोर्स. फोर्स फॉर विच वर्क डन is either zero or constant is called as which kind of force? Conservative force. Is that clear or not? अब ध्यान से देखो, ऐसा भी तो वेरिएबल आ सकता है ना. जैसे मान लो अगर तुमसे मैंने पूछ दिया इंटीग्रल एक्स स्क्वायर डीएक्स, इंटीग्रल एक्स स्क्वायर डीवाई हो और प्लस वाई स्क्वायर डीएक्स हो, तो ये सॉल्व नहीं हो सकता, ये परफेक्ट डिफरेंशियल वगैरह फॉर्म नहीं है, इसका आंसर ही नहीं आ पाएगा. आर यू एबल टू गेट मी और नॉट? तो यहाँ पे इन सब केसेस के लिए जो वर्क डन आएगा, वो जो फोर्सेस है जिसके लिए हम वर्क डन निकालें, द फोर्सेस फॉर विच वर्क डन changes for different values that are called as non-conservative force. क्या बोलेंगे इसको अपन? Non-conservative force. Are you able to get me or not? मेरी बात समझ में आई या नहीं है? तो इसकी जो डिटेल डिस्क्रिप्शन है कंजर्वेटिव और नॉन कंजर्वेटिव की, हम पकड़ने वाले हैं कल. आर एबल टू गेट मी? कल क्लास नहीं होगा, वेंजडे है ना. अच्छा, एक थोड़ा सा और आज आज कंप्लीट ही मार डालते हैं यार, मजा आ रहा है, फ्लो आ गया मेरे पास. चलो तो अब ध्यान से देखते हैं. मान लो 2 पॉइंट्स है. अब इस चीज की वैल्यूएशन को समझते हैं, मतलब इस चीज को अच्छे से समझते हैं, पकड़ने की कोशिश करते हैं. मान लो अगर 2 पॉइंट्स है ए और बी, है ना. फिर मान लो, हेलो, मैं बोला कि लेट्स कंसिडर 2 पॉइंट्स ए एंड बी. ओके. एंड आई एम अ पर्सन हु इज वॉकिंग ओवर हियर, मतलब मैंने इनके पीछे ऐसे ऐसे पाथ बना दिया, मतलब एक बाइसिकल वाला है जो इस पॉइंट ए से पॉइंट बी जा रहा है कि नहीं. अब ये पॉइंट ए से पॉइंट बी किसी भी वे में जा सकता है ना, ऐसा कुछ ऐसा पाथ भी पकड़ के जा सकता है, ऐसे भी जा सकता है कि नहीं. अलग अलग पाथ है, मतलब समझो जरा, अलग अलग पाथ है तो अलग अलग इक्वेशंस होंगे. ध्यान से देखा जाए तो हर पाथ पे, अगर मान लो हर पाथ को मैंने सेलेक्ट किया, तो हर पाथ की अलग अलग वर्क आनी चाहिए ना जी. तो अब ध्यान से समझो कि मान लो ये पाथ, अरे मैंने बहुत उल्टा सीधा पाथ बना दिया यार, मजा ही नहीं आया मार्क करने में. मान लो पॉइंट ए और बी चलना स्टार्ट किया. पहला पाथ ये, दूसरा पाथ ये, तीसरा पाथ ये, चौथा पाथ ऐसा, और पांचवा पाथ स्ट्रेट. 5 different paths are there. 1, 2, 3, 4 and 5. And I'm going from all different paths. All different paths I am selecting. Are you able to get me or not? Now, if force is variable, अगर force कैसा मिला, force अभी variable है ना, इसकी कोई एक ही पॉइंट कोऑर्डिनेट होगी एक्स वाई जेड, और बी की भी मान लो थोड़ा अच्छे से लिखते हैं, तो ए की कोऑर्डिनेट जो होगी वो मान लो x1 y1 और ये है z1, बी की कोऑर्डिनेट होगी x2 y2 और क्या होगी z2। और फोर्स कैसा है, वेरिएबल, फोर्स कैसा है, वेरिएबल, है ना। लेकिन ध्यान से देखो तो अगर मेरा फोर्स वेरिएबल है हमें उससे कुछ फर्क नहीं पड़ता। अगर हमें x1 z1 y1 और x2 z2 y2 पता है, z2 पता है, और फोर्स ऐसा है कि इसके लिए जो वर्क है वो सॉल्व हो सकता है। वर्क कैसा हो सकता है, इंटीग्रेशन सॉल्वेबल है, इंटीग्रेशन इज सॉल्वेबल। तो अगर इंटीग्रेशन सॉल्वेबल होगा तो देखो ध्यान से, फोर्स वेरिएबल होते हैं और इंटीग्रेशन अगर सॉल्वेबल है तो वो इस पाथ के ऊपर डिपेंड नहीं करते हैं, बल्कि इनिशियल और फाइनल कोऑर्डिनेट के ऊपर डिपेंड कर रहे हैं या नहीं कर रहे हैं, कर रहे हैं ना। तो ध्यान से देखो, इफ आई सेलेक्ट ऑल दिस पाथ्स एंड इफ आई नो x1 y2 z2 और इंटीग्रेशन इज सॉल्वेबल although the force is variable, the work done will only depend upon what, initial point and फाइनल पॉइंट। तभी तो मेरा वर्क डन कैसा आएगा, कांस्टेंट। अगर वर्क डन अपन का कांस्टेंट आ गया फॉर दिस वेरिएबल फोर्स, इसका मतलब क्या हुआ कि द वर्क डन, द फर्स्ट, हाँ फर्स्ट पॉइंट आया कि वर्क डन इज इंडिपेंडेंट ऑफ पाथ। सेकेंड पॉइंट आया कि वर्क डन डिपेंड्स अपॉन इनिशियल एंड फाइनल पॉइंट, डिपेंड्स ऑन ओनली initial and final point. Are you able to get me or not? Is that clear or not? और इसी चीज को तो हमने बोला कि कंजर्व सर, अगर कांस्टेंट वर्क आ गया तो इसी चीज को हम बोल रहे हैं ना कंजर्वेटिव फोर्स। कौन सा फोर्स बोल रहे हैं? सो बेसिकली अगर तुम्हारे पास कंजर्वेटिव फोर्स है तो उसकी प्रॉपर्टी क्या होगी कि सर कोई भी पाथ सेलेक्ट कर लो, जो वर्क डन अलोंग वन होगा वो वर्क डन अलोंग टू होगा, and that will be equal to work done along third region होगा, that will be exactly equal to work done along fourth region होगा, that will be exactly equal to work done along fifth region, and that's the nature of which kind of force is conservative forces only. So basically, conservative force are not defined with respect to a force definition. They are defined with respect to a work definition. कि conservative force के तीन प्रॉपर्टी सबसे पहले आएंगे। पहला कि इंटीग्रेशन की वैल्यू कांस्टेंट आएगी। कैसी आएगी? दूसरी बात कि वो पाथ इंडिपेंडेंट होगा। तीसरी बात कि वो सिर्फ और सिर्फ इनिशियल पॉइंट पे डिपेंड करेगा। इज दैट क्लियर और नॉट? पॉइंट के ऊपर। अगर नॉन कंजर्वेटिव हो गया तो तीनों पाथ के लिए जो इक्वेशन होगी वो कैसी होगी बेटा? अलग अलग। इफ इट इज नॉन कंजर्वेटिव फोर्स तो पहले तो इंटीग्रेशन की जो वैल्यू आएगी वो क्या होगी? अलग अलग। इट विल बी काइंड ऑफ अनसॉल्वेबल एंड इट विल बी, इट मींस दैट वर्क डन अलोंग वन विल बी टोटली डिफरेंट फ्रॉम वर्क डन अलोंग टू, totally different from work done along 3, and that will be totally different from work done along 4th and 5th. Is that clear or not? Understood or not? मजा आया? ठीक, तो नॉन कंजर्वेटिव फोर्स, कंजर्वेटिव फोर्स पढ़ लिया। कल वेंसडे को जब हम मिलेंगे तो स्प्रिंग और फ्रिक्शन के बारे में बात करेंगे, थोड़ा कंजर्वेटिव और नॉन कंजर्वेटिव को इन रिवर्सिबल और इरिवर्सिबल के टर्म्स में दर्शाने का कोशिश करेंगे, एंड देन आई मूव अहेड। ओके ओके, तब तक के लिए टाटा बाय बाय, सी यू। कुछ डाउट हो तो भेज देना मेरे को, है ना?